area to attend our Zoom meeting. Okay. Anyway, our topic for today will be about graphs. Sino na yung, have all of you watched the videos that I have posted last time in YouTube, or scanned or studied the materials that I have uploaded? Have you all done it? Yes? Only Shaina did? How about the others? So you won't be able to, like, you will have a hard time following if you are not able to browse the materials that I have added. Okay, so can you tell me what you have learned so far from the previous topic that I have uploaded? So any concept or topic. Ikaw lang.
I'm in some message feed.
Sa laptop. Okay. So, nahirapan na ako. Gusto mo din.
I love you can na tapos mag-watch mo lang ako.
Ma-watch ka lang sa video. Sure ka?
Yes. Alright. Guys.
Okay. So anyway, what have you learned so far from the lessons from last time? Any concepts or topics that you remember? Anyone? Okay. Okay, wala get. Okay, about the graph, ma'am, it is made up of vertices and edges, correct? A graph is made up of vertices and edges. So what are two main kinds of graphs that we have discussed so far? Anyone? Okay, so RJ said it's directed and undirected graphs. Okay, so what's the difference between directed and undirected? Yeah, so like your classmates, you can type in chat if you are shy to talk. Okay, so what's the difference between directed and undirected graphs? Adrian?
Because
Yes.
it was Saturday, but if you like, I really forgot.
Okay, that's okay. So anyway, when we say directed na graph, it's the edges will have directions. Okay, sino nagsabi ito? Directed graphs are one way and undirected graphs are two way. So directed graphs have the edges have directions. Okay, and then for example, if you have A and B na vertices, and if you have a directed na path from A to B, so there is a one-way path from A to B only, but not B to A. Okay, but if it is undirected, so there is an undirected na edge between two vertices, then that means that there is a path between A to B and then B to A. Okay. Isomorphism. So what do you remember about isomorphic graphs? Anyone? Crystally? What do you remember about isomorphic graphs? What about Stephen? Emerson? Can you remember? How can you determine if two graphs are isomorphic?
Is it
Yes.
because there's vertex A and then there's vertex B and then vertex A is connected to vertex B, but vertex B is not connected to itself
To itself.
as well as vertex A. Is that isomorphic?
when we deal with isomorphic na graphs, we deal with two graphs. Two graphs. And when we deal with two graphs, they basically have the same structure. And ways on how we can determine if they are isomorphic is that there is a one-to-one, on-to na mapping in between these two. So for example, if in this graph A, and then in graph B, you map a certain vertex to another vertex in the graph B. Okay, so kung ilan yung edges dito sa graph 1, yan din yung number of edges sa graph 2, and same din yung mga going ng mga degrees. Okay? So, anyway, looks like a lot of you have not watched the recordings yet kahit medyo more than 1 week na yun na-upload. Okay, so do not just read the materials that are given because the explanations are more detailed in the recordings. Okay? Anyway, let us try to start with our topic for today. Our topic for today is more on connectivity. Are you still able to hear me even if okay, so our topic for today will be about well, I mean, are you section 1, come on. You can use, do you have your laptops? Yeah, you can use the rooms. Section 2, come on. Wala ako projector, galing di. Tingala lang, wala na naman ako naglanta sa mga kwan. Hi. Can you see it? Nag-reflect siya dami. Yeah. Sige, sorry, we don't have any room available. I want to have a class, but okay, never mind. Okay, dito na lang. So we'll have a hybrid na class. So some of your classmates are here and some are there. Okay, so anyway, we are going to talk about connectivity. So since you are here, I'm going to ask sa mga newcomers, ano yung mga na-remember nyo na topics from last time? What else? Adjacency matrix, right? And how do you represent the graphs? Adjacency list, what else? Adjacency matrix, and what else? Incidence matrix also. Okay? Cute yun. Wait, 4 p.m. ang exam nyo? So, tingnan ko damo absent. Sige today we are going to talk about connectivity. Okay, and the basic na idea of connectivity is that in a graph, there is a reachability among sa mga online, can you hear me? Okay. Sige, let me know if you hindi nyo marinig. So in a graph, reachability among the vertices by traversing the edges. So for example, in a city-to-city road network, if one city can be reached from another city, so you can treat the cities as reachable siya, then there is a path between them. So the problems if let's say if you want to determine whether a message can be sent between two computers using intermediate na link. So for example, dito connected tayo sa isang network, right? So merong isang network hindi makakonect or hindi siya makakonect sa sa server. So ano kaya yung problem? So we can check our network, right? If merong mga problem, baka merong mga disconnected na mga computers with our server. Okay? And the sequence of edges. So we have the concept of path. wherein it is a sequence of edges that begins at a vertex of a graph and travels vertex to vertex along edges of a graph, always connecting pairs of adjacent vertices. So sequence of edges siya. So for example, sa itong graph na to, we can see here a path, yung galing sa U, starting here, up to here. Okay? And sabi dito, it travels vertex to vertex along edges. So there is a path from U to 1, and then 1 to 4, and then 4 to 5, and then 5 to V. Okay? Gets? Yeah, so that is an example of a path. So itong mga mga 2 and 3 na nasa red, vertices sila ng graph but hindi sila nadaanan sa path. Right? Okay, so ano naman yung path for the directed na graphs? So a path origin. Hindi yan yung destination niya. In of G. So ito yung mga edges mo. E1 of edge 1 is composing a vertex na path from x sub 0 to x sub 1. Okay, and then followed by so you can parang ganito siya. X sub 1, x sub and then edge 2 and so on and so forth. Gets nyo ba? Sige. So where parang hindi kayo nakatulog. Math ba yung exam no? I see. So anyway, where destination is said to pass through these vertices na x sub 0, x sub 1, x sub 2 until x sub n, or traverses also the edges e sub 1, then e sub 2 until the e sub n. So for simple graphs, the sequence is x sub 0, x sub 1 until x sub n. But in directed na mga mga multigraphs, when it is unnecessary to distinguish between their edges, we can use a sequence of vertices to represent the path. Okay, so we have what we call a circuit or a cycle. So yung dito, meron tayong path. Tapos dito ka nagsimula. This is also the V is the destination. But you can see that U and V are equal. So meaning, kung saan ka nanggaling, dun ka din babalik. So that is your cycle or circuit. And the length of path is greater than 0. Okay, in simple path naman, it does not contain an edge more than 1. So an undirected na graph is connected if there exists a simple path between every pair of vertices. So sinasabi lang yan na we have a graph V of E and then is connected siya since you have the vertices which is composed of V1, V2, V3, V4, and then V5. Okay, and then there exists a path between V sub I to V sub J. So meaning, galing dito sa V sub 1, let's say, papunta sa V sub 4, papunta sa V sub 5, and then papunta dito sa, let's say, so pag nasa V to V2 or V1, anywhere in the path. So you can say that it is connected. Okay, so there is a way to go to any vertex from starting from this graph G1 is connected since any vertex you can go to any vertex. Why? Because bakit siya disconnected?
Not all vertices.
You're right. Not all vertices are connected. So, connected yung vertices A, B, at saka C. These vertices have if you just remove just one vertex, it produces. So, for example, meron tayo ditong graph V1 composing of vertices V1, V2, V3, V4, at saka V5. So, si articulation na point or cut vertex, the removal of a cut vertex from a connected graph produces a graph that is not connected. So, ilan na yung connected components mo? Dalawa na, right? So you have this subgraph and then this subgraph because you have removed this specific na vertex. Okay? You okay? No, not blinking. Wait lang. Let me know if you're still okay. Can you please turn on the aircon? Feeling ko naka-off siya. I'm not sure. Thank you. Now, going back, an edge whose removal produces a subgraph with more connected components than in original na graph. So ito na yung example natin kanina. So in this case, meron tayong dalawang connected na components compared kanina sa hindi mo tinanggal yung cut vertex. Okay? Now, dito, tingnan natin. Hello? Are you okay? Sige. Okay. Sige, let me know sa chat or email. So anyway, we have the undirected na graphs here. So for the first na graph, G1, can you identify kung ano yung mga cut vertex dito? So pag tinanggal mo yung pag tinanggal mo yung articulation or the cut vertex, magkakaroon ka ng more subgraphs, more connected components. The what? C? Sige. If, let's say, tinanggal natin si C. Right, it is correct. Kasi ano yung mga subgraph na ipoproduce niya? So, it will be A, B, D. Else. E. So, pag tinanggal natin si E, so we will have a subgraph containing A, D, B, C, at saka F, G, at saka H. Okay, so si E. Ano pa yung mga ibang articulation na vertex? Si B, right. Kasi pag tinanggal natin si B, si A na lang yung matitira sa isang subgraph, and then the rest will contain D, C, F, E, G, and saka H. Okay? So, let's say itong vertex na to. Can we consider this one as a cut vertex? Yes or no? No. Bakit no? Kasi it still produces one na subgraph. Okay? So, kumbaga connected pa rin yung graph mo. Okay? Dito. Ano yung cut vertex mo dito? C. Okay, tatanggalin natin si C. So, yung matitira na lang ay si AB at saka itong si AB at saka si D. Okay? So, what about for G3? Any remove A if we remove A, hindi pa din. And whenever A and B are vertices in a graph. So if there is an undirected na graph between every two vertices in the underlying path, masasabi natin na ano siya, from B to A. Okay? So, what about for G2? Assuming itong si A, tsaka si B, tsaka si B. So, right? No. And then, but you have a way from B to A, and then at saka, pag titingnan mo kasi sa undirected graph nila, ito yung to B to C. But dito sa directed graph, let's say itong directed graph niya, wala ka ng way from A to from okay, so for example dito, for each of the following or strongly connected or weakly connected or not connected at all, complete or not complete. So itong si graph A, so we can consider it as connected, and then it is also complete. Connect, yes. Right, So, yung every vertex is connected to every other na vertex. Okay? At saka undirected na graph din siya. So, what about yung graph D? Also complete. Kasi you have a way from A to B and then B to A. Tsaka so, yung sa cyclic is that your U is equal to B or yung origin mo is equal to your destination. Connected na graph din. What about for graph C? So, graph C is not connected. Okay? Kasi, meron tayong dalawang subgraph dito. Subgraph, but they are not, this vertex is not connected to this or this vertex. Okay, at saka, it is also not complete. And siya nga, non-connected na siya. So, of course, not connected. And then, it is not complete. Right? In a direct, strongly connected. The subgraphs of a graph G that are strongly connected. So, for example, starting from any vertex. strongly connected na components. Do you still follow? Okay. So, punta tayo dito sa topic ng isomorphism. This would be better if nasa board. Sorry. So anyway, let's go back to the simple graph A is an existence of a simple circuit of length K. So tingnan natin ilan yung edges ni J. 4? Edges ni
Ang galagan. Ang galagan. Late ang percent.
I see. Ilan yung edges ni J? Number of vertices, 6. Then vertices, 6 din siya. Itong si U to V, U1 to V1, then U2 to V2, U3 to V3, and then U4 to V4. Okay? So, ilan yung incidents or incoming or adjacent na edges ni U1? Ni U1, dalawa. Right? Si V1, dalawa din. Si U6, tatlo din siya. Si V6, 3 din. Okay, si U2, ilan? Tatlo. Si V2, 3. The 3, and then this one is 3. U3 is 3, 3. And then 2, and then 2. So, same sila ng edges. Tapos, same sila ng vertices. Tapos, same din yung degree ng each. Okay, but can we consider it as isomorphic? Yes or no? Why?
There's no path.
Right, there is no path. Tsaka makikita natin na may cycle dito. There is a cycle here. But in here, there is none. Okay? Walang cycle dito. And same is true for V5, V3, V4. Then, which is not found in the graph G. Okay? Yeah, so we cannot really say that these are isomorphic. Okay, so even if they have the same number of edges, same number of vertices, or same degree for each na vertex. Okay? Okay, now let's go to Euler and Hamilton. Have you heard about this?
Euler's name.
Huh?
Euler's using logarithms.
Right, Euler and Hamilton. Sige. We have this bridge here, 7 bridges of Königsberg, Germany. Anyway, hindi ko alam kung paano talaga yung right pronunciation nito. So the residents of Königsberg, Germany wondered if it was possible to take a walking tour of the town that crossed each of the 7 bridges over the Presel River, exactly one. So, gusto nila na tour around this place. But, iko-cross lang once. Okay, so, at some node, and take a walk that uses each edge exactly once and ends at the starting node. To A, then A to B, or ganyan. So, dadaan you can pass through all the bridges. Would it be possible? You can try in your you can think in your mind. Right. Right. This bridge. Yeah. Oh, hard. But so for example dito. Represented here. And then A to B. Okay. To C to D. Saan ka dadaan? A to D here. And then E to D. And each edge exactly once. Okay, it is not possible. So later we will discuss why. Bakit? So it's for example, and then yeah. So merong isang at least one bridge. Yan pa, or Eulerian trail or Euler walk. And in a graph is a path that uses each edge precisely once. So if we can find such path, then we can say that the graph is traversable. Okay, so for example, dito, we have a graph here, and we can start, let's say, from 0, then here, each na edge exactly once. So you have one path. Pwede ka naman makabalik sa vertex, pero yung mga edge, hindi mo na siya pwedeng nabigay. Pwede kang dumaan ulit sa vertex, but not the edge. Okay? Yeah. Yung Eulerian na cycle naman is that it is a cycle that uses each edge precisely once. If such a cycle exists, that then 1 to 0, then 0 to 3. We have a path that traverses all the edges exactly once. And yung origin mo, which is 0, is also equal to your destination. E to E, then E to D, then let's say, sige, D to A muna. So there are different path. So pag sasagot kayo sa exam, pwedeng yung classmate mo, iba yung sagot niya sa sagot mo. Because you might start with, you might go through a different na path. So nagets niyo ba? Okay. So ano yung difference sa Euler na path and Euler na circuit? Ay, circuit cycle, right. Anong difference nga? Ano nga ulit yung yung topic of Euler? So you that traverses through the edges only once. You can pass through all the edges only once. Pero sa path is that hindi equal yung origin mo sa destination. But sa path, makaka-traverse ka lahat ng edges only once, pero babalik ka sa pinanggalingan. So, kanina, the Königsberg na problem is not Eulerian. So, there is no trace that a graph will contain an and we'll show an example later. And then a graph will contain an Euler circuit or cycle if all vertices have even a degree. Okay, so pag titingnan na natin itong so pwede yes? Weakly connected. Oh, yeah. Cool. May namang where ang CL1? Oh my. Hindi niyo pa nagamit ang CL1 din? Okay. Sige. Sige, start tayo from Dire. So yeah, it is possible. Okay, so you start from F, A, then B, C, D, E, and then C. Okay, tapos dito naman sa isa, you can start from 0, then you go to here. Okay, so titingnan natin, di ba Euler path ito? Kasi nga hindi siya natin, magko-contain yung graph ng Euler path if it contains at most 2 vertices of y. So yung gagawin nyo natin is titingnan natin lahat ng degree ng F, ay, ano ba yun? This is 3. Si F is 3, D is 2, tsaka E is 2. So, saan yung mga even? This one. Ay, odd pala. Sorry. Saan yung mga odd? This C, at tsaka yung F. So, magko-contain siya ng Euler kasi may dalawa lang siya. Ito naman, si another graph, ito 2, and then this one is 2, 3, 2, at saka 1. So, saan yung mga odd? This graph 0 and then graph 4. So, dalawa din yung odd. Okay, so it contains an Euler na path. So, dito din naman. So, a graph will, saan dito yung yung nagko-contain ng Euler na path? So, pwede, di ba? Yeah. So, dito naman sa kabila, tingnan natin. Let me know. So, it also contains an Euler path. Right? Kita nyo ba? Nakita nyo yung process of how it was done. And then, how about yung sa G3? Paano kaya to? So it is nice to practice on this. So si A, vertices niya 2, then this one is 3, 3 at saka 2. So dalawa lang. So okay. So this one is 2, then this one is 4. At saka 4 and 3. So ilan yung odd? Dalawa lang. So this is also contains Euler. And we have also proven it earlier. Diba? At saka ito naman, this contains 3, 3, 3. So more than na siya, more than 2. So it's no longer an Euler. Does not contain an Euler path. So ang graph naman will contain an Euler circuit if all vertices have here. Okay? Yeah. So let us check. Or you can check also if even na talaga. So sa graph 2, this is 2, 2, and then how many? 4. Then for C, it is 4. And then for E, 2. D is 2. Okay, and then this one. And dito naman, we have 2, 2, circuit. So for this challenge, so you can do it yourself. So you can check if Euler path ito or Euler na circuit. Does it contain an Euler path or Euler circuit? Circuit? Bakit? Bakit? Lahat even? Okay. Sige. Yung E lang yung apat yung edges niya, adjacent na vertices, pero the rest are 2. So yung second, how about yung second?
No.
Not, hindi talaga siya. Kasi A, B, C, at saka D, may tatlo yung edges niya. Okay? And then yung last naman, may path lang siya. Saan yung dalawang 3? A at saka B. Okay. Very good. So sa mga online, you can also check it. So this one is circuit. Yung pangalawa is path. Ay, not pala. And then yung last is okay. Sige. Busy sila, busy. Sige, move on ito, guys. So instead of looking for a circuit that covers every edge one, sometimes we are interested in a circuit that visits every vertex naman. So kanina you have misunderstood, right? So your edges yung kanina, but this time, we want to visit every vertex one. So this concept would be helpful, for example, for a delivery person wanting to stop at every delivery location rather than going down every street. So for example, ito, we have a graph here and we can navigate from here to here to here and then here to this. So we have visited all the vertices here. So we were able to visit all the vertices. Okay, at once lang. Hamiltonian. So, yung sa edges, Euler. Pag sa vertices, Hamilton. Okay? So, sa Hamiltonian na path, it is also called as a traceable na path. And it is a path that visits each vertex exactly once. Called as Hamiltonian circuit or vertex tour or graph cycle. So it visits each vertex exactly once except for the starting vertex, which is visited once at the start and once again at the end. Okay. So let's see. Let's have an example. So anyway, yung dito is that any Hamiltonian cycle can be converted into a path, Hamiltonian na path, by just removing one of its edges. So sige, ito tingnan natin. So we can go from here to here, right? So we can visit all the vertices, right? But it's not possible na bumalik ka sa start. So yung sa Hamiltonian graph, compared sa Euler circuit, wala tayong theorem dito to determine whether or not a Hamiltonian circuit exists for all the graphs. So sa Euler kanina, meron tayong Euler path if at most na 2 na vertices, degree niya ay odd. At saka circuit if lahat ng degree mo ay even. But for Hamiltonian, yung circuit or graph, wala. There is no theorem for us to do that. So, yeah. But maybe one of you can find it, di ba? Maybe baka kayo yung makahanap ng solusyon. Okay, so in this graph, on the other hand, is this Hamiltonian or not? Is it possible? Sige, let's say we start here. Okay. And then we can go to the next, no?
Next.
Okay, and then okay, so it is Hamiltonian, Hamiltonian siya. Yes, pero is this a circuit or path? Path lang. Okay. So what about this? So this one has a Hamiltonian na path but not also a circuit. Okay. And then what about this one? So Hamiltonian circuit does not exist. So path din siya. So tingnan natin. So let's say we start from here. Yeah. Now we can visit all the vertices. Okay? Kaya? Diba, it's one of the most fun. Pero pag ipa-implement sa programming, might be so, meron tayong Euler na tour, but not Hamiltonian na path. Okay, kasi we can visit every edge, but dito babalik. Now, nasaan na tayo? Shortest path. Don't joke. Anyway, shortest path na problem. So many problems can be modeled using graphs with weights assigned to their edges. So we can represent cities by vertices and the flights by edges. And we can assign distances between cities to the edge, or we can assign flight times to edge, and then we can assign fears to edges. So, for example, ito, meron tayong several na mga airlines or cities. At saka we have, let's say, I'm not sure if this is distance or plane fare, pero assume na lang natin na distance siya. So what is the shortest na way, let's say, to go from San Francisco to Boston or from San Francisco to Miami? Okay, so we can make use of the weights that are assigned to the edges. So we can also look at the flight times. So what is the shortest time that we can get para mas mabilis yung path? Okay, yung travel. Number assigned to each edge, and it can be used to model communication networks or communication costs, response times, and the distance between computers, and so on and so forth. So what is the shortest path na algorithm? So we generalize distance to weighted na setting, and we have a directed graph G composing of vertices and edges with weight function, a weight function that maps E to R, wherein yung E, yun yung edges mo. Yung R, ito yung weights or mga values that are assigned to the edges. Okay, there is a mapping between the edge as well as the weight. Until dk, and this will be the weight of the path. Kumbaga, lahat ng mga edges, lahat ng weight sa path na dadaanan mo, i-add mo lang sila. Okay, so yan ang yung gusto niyang sabihin. So you have for all I to k minus 1, so meaning lahat ito ng vertices na nasa path. So we take the sum of the weight of v sub I to v sub I plus 1. For example, meron ka ditong v1 and then v2 and then we have the v3 here. So it is a path. Okay, so meron kang e1, let's say, at saka itong e2. Okay, so si e1, let's see, mga weights na assigned sa kanya. So, yung weight of the path is we simply add this 3 plus 4. Okay, so that is v sub 1, weight from v2 to v3. Yeah, gets nyo ba? All pairs at saka unweighted. So the topic for this lecture is the single source or single na destination, wherein we find the shortest path from a given source na vertex S to each of the vertices. And also for the single pair, given two vertices, we find the shortest path between them. And yung all pairs naman, we find the shortest path for every other vertices. Okay? So anyway, yung gagamitin natin dito is, it is read daw as Dijkstra. Okay. So ano ba yung Dijkstra nito? Si Dijkstra is actually a person. So he is a Dutch na computer scientist from the Netherlands and he received the Turing na award. Okay, so madami pang the single source and single path is you have one source and you find the shortest path from a source vertex V to all other vertices in the graph. So we will have some weights. So it can work on both directed and undirected na weights. But here in the Dijkstra, particularly, all edges must have non-negative na weights. Okay, so merong non-negative meaning one end. So sige, tingnan natin to. For example, yung problem is starting from this vertex to this vertex, ano yung shortest path papunta dito? Yan yung question. So, yung ibibigay niya is yung actual path. Okay, which is 1, 3, and then 5. So, sige, tingnan natin. Yung implementation ng Dijkstra. So, we have what we call an edge relaxation, wherein you try to lower the cost of getting to a vertex by using another vertex. So, for example, meron ka ditong source vertex. Say na merong path dito from S to V at saka merong path din from S to U at saka U to V. Okay, so ano yung dalawang possible path from S to V? So that would be V of V or you add U, V at saka yung U to V. Okay, so ano yung i-consider natin? Yung anong path? The longer one, right? So we consider an edge U and V. So currently, if ang sum ng ito ng D of U plus the weight of U plus V is less than D of V, for example, yung V is V of D kunwari. Pero nakahanap tayo ng mas shorter yung path. Then we set that the distance going to V is are you listening? Where? Hindi na ako magtuon sa math kay wala man yung akong pinasabta. So, the joke lang, pero program ka mo. That's why you have to study in advance. Kasi, yeah. Para before ng exam, chill-chill na nakamo. Joke lang. Anyway, mas fun naman exam sa una. Kaya weekend, di ako exam. Yeah. Tapos magkatod yung mga students sa dorm for me pa wala tubig. So, ka-exam, mga wala kaligo. Nakapajama, halid sa dorm. Okay, going back. So, yung edge relaxation. Yan yung mga distance going to that vertex. Distance going to and a shorter path from B to U. And anyway, sige, mamaya na yan. Etong, mamaya ko na ito babalikan. Okay? Let's start muna with an illustration. So, how to move the shortest way. Bakit how to move on? Okay. Because we had reportings before. So, ito yung pinresent ko. And I was... So, if you're heartbroken, what would you do to move on faster? So, anyway, ang corny na ng undergrad. Okay, so let's say, pupunta ka from A to E. Ito yung graph mo, A to E. So, ano yung shortest path from A to E? Yan yung question. Okay, so, sa each na vertex is infinity pa siya. So, as you can see, infinity, so on. So, yan yung initialization. And as you can see, all the weights are non-negative. Okay? Now, you start from A kasi yan yung source vertex natin. So, we set the source ni A, which is B at saka C. Okay? What is the distance from A to B? 7. So, we change D of U to 7. D of B pala to 7. At galing sa A. At saka A to C is 2. Right? So, ito, 2 to A. Now, wala pang path from A to D at saka A to E. Okay, now, kunin natin yung pinaka mababa. So, it is C. C, right? So, si C, dito na tayo. So, assuming dito tayo kay C. So, C is, isi-set ulit natin. C to A. Meron bang path C to A? Wala. So, 0. Then, C to B, it is 2. So, 2 plus 2. 4C. Okay? Coming from C. Tapos, i-replace natin kumbaga yung 7 na A to 4. Kasi yan yung shortest na path. Okay? Then, C to C, and 2A, mula sa taas kanina. C to D. C to D is 2 plus 8. So, 10C. Tapos, C to E, 2 plus 7. 2 plus 5, so that will be 7. Okay? Next is, i-visit natin si B. Kailangan natin i-traverse yung mga lahat ng andito, vertices. So, si B, nasa B na tayo. So, kanina, ni-replace natin 4 na going to B with this path. B to A, meron ba? Wala. B to B, so same lang. So, 4C, copy from sa taas. Then, B to C. Sa C, A to C is 2A. So, mas grabe yung cost, kumbaga, kung pupunta ka B to C. So, hindi natin i-replace yung dating value. Okay? Tapos, B to D. Nasaan tayo? B to D. Is 4 plus 1. So, 5B. Tapos, B to E, wala. So, retain ng old commute. Now, travel naman tayo sa D. That is the smallest here. D to A, still 0. Then D to B, walang way. So, copy the top. Then D to C. Meron ba? D to C? Wala. Right? So, copy. And then, D to D, copy lang din yung sa taas. Tsaka D to E. So, 5. Currently, yung distance to D is 5 to 7. 5 plus 5 pala, 10. Mas ano dito? Mas maliit yung 7 kanina na galing sa C. So, retain natin to. So, now, nasa E na tayo. So, wala na. Yung si E, pupunta lang naman siya kay B. So, copy lang ito lahat sa E pala. It is 7 plus 5. It is 12. So, hindi natin to papalitan ng 12. 5 pa rin siya. Okay? So, ayan. So, yung way natin ay you look at the column na part. So, si E galing kay C. Tsaka si yun na yung source vertex natin. So, nag-backtrack ka lang kumbaga. So, our path then is 2 to 5. So, it's okay. What about yung next na section? Dito na kayo? Okay. I'm not sure if the okay. Nasa planar graph na tayo. So, ang dami na nating discuss. So, the first one is the Euler. Then, next is the Hamiltonian. And then, shortest path, which is the Dijkstra. So, I think I'll create a specific na, separate na video for Dijkstra. Just for you to go back to. And then, next would be the planar na graph. So, ano yung planar na graph? This is also fun. So, if we call it a planar na graph, if a certain graph G can be drawn in the plane with its edges intersecting only at vertices of G, but walang nag-intersect na lines. Walang nag-intersect na mga lines. So, such a drawing of G is called an embedding of G in the plane. So, for example, meron tayo dito. Itong si graph. So, tinanggalan natin itong edge na to. At saka, let's say, we can connect it here. Okay? So, same lang siya kung vertices lang sila nag-intersect. Gets nyo ba? Sige. So, eto naman, this is another example on how you can, parang ni-restructure nyo lang siya kumbaga. You retain still yung mga edges, na-restructure lang siya. Now, an Euler's na planar graph theorem states that for a connected na planar and then E will be the number of edges. So, let's see it here. Sabi natin kanila, yung theorem ay V plus R, tsaka 2 plus E. Okay? Wherein yung V ay number of vertices. So, number of vertices mo dito ay 4. 1, 2, 3, at saka 4. Okay? Anong number of edges mo? Number of edges?
6.
6. 1, 2, 3, 4, 5, at saka 6. Open. So, 6. Tsaka yung regions ay dinidivide mo into plane or faces yung graph mo. So this one is region 1, then region 2, then region 3, at saka you are including the outside, infinite region. So V plus R is equal to 2 plus E. So that would be 4 plus 4 is equal to 2 plus 6. And they are indeed equal. Okay? So it is the same with this. You can check later here. So what about this one? Can you transform this into a planar graph? So you can try it in your mind. Or you can write it down on your paper if you have any paper. Okay. So ano, meron na ba kayo? May dalawang edge na nag-intersect sa ano. So anong gagawin nyo? Ilang edge yung i-move nyo? Dalawa lang. Okay, so for example, A, B, C, D at saka E. Anong edge yung unang i-move nyo, let's say? Anong edge?
B and D.
A and C. So tanggalin natin ito. So let's say, gawin natin here. Ano pa? A2? E. Yeah, things like that. So wala na nag-intersect. Okay? Yeah. Yes, okay lang. There, as I said, there will be a lot of different answers. So pag nagkamali sa checking, you can ask, ma'am, may answers to that. Okay. Now, nasa last topic na tayo. Then you can study on your math exam. So what about for the graph coloring? So it is the assignment of colors. And by the way, hindi kayo nanonood ng mga recordings, hindi din kayo nagsascan ng mga material. So your scores will depend doon sa sa effort din na binibigay niya sa pagbabasa. Okay? May yung grade. Anyway, graph coloring is the assignment of colors, and it's almost always taken to be consecutive integers starting from 1 without loss of generality to certain objects in a graph. So, di ba na-experience yung graph coloring? Yeah. Saan niya siya ginawa? Saan? Bipartite.
Oh,
right?
bipartite.
Ano nga ulit yung bipartite? To yung mga vertices of this one set and then the vertices of the other set are disconnected. But so merong yay. Tapos ano na next? So paano nyo in-apply yung graph coloring doon? Different color yung neighbors. Okay. So for example, pag itong dalawang edge na to, hindi sila pwedeng dalawang red or dalawang blue. Dapat magkaiba sila ng color. Okay? Yeah. So the assignment of colors to the vertices of the graph such that proper coloring takes place such that hindi same yung color ng mga adjacent na vertices. Okay, so that's the problem of vertex. I will not follow the colors here. For example, red ito. So meaning yung katabi niya ay dalawang blue. Okay? So itong si pwede nating actually gawing red to. Rather, red na lang siya. Okay? And then we cannot make this as blue because merong violet siya. So ilang color yung gagamitin natin dito? Tatlo. Diba? Tapos, let's say ito naman siya. So, C4. So, dalawa. Tapos, dito naman, let's say, blue. Tsaka, say, red. Red. Tapos, ito, gagawin kong blue ito. Right? Blue. Tapos, this will not be red or blue. So, let's say, violet. So, tatlong colors din. Yeah, dito sa K4, it will be 4 na colors. Yeah, so the problem of finding a minimum na coloring of a graph is NP hard. So kumbaga, it's not yet solved pa talaga. So it's a difficult na problem. So baka din sa batch nyo, kayo yung makahanap ng solusyon. So, then, wait lang, gets nyo ba yung topics natin for today? Are you sure? Sige, can we meet on Thursday again? Sige, wow! We will meet face-to-face on Thursday for our last meeting. So, as if naman nakikita tayo every week. During finals na. And then, no? Sa during finals naman. Oo. Amo na ng long exam. Kumbaga, no more finals na exam. Ano na lang siya, yun na yung long exam nyo. Kumbaga, dalawa. Yeah, both for 27 and anong hindi na mag-previous exam? Hindi na. Ano na lang. Wala na. Sa mga ma-removals na lang, amo na lang na ang study from starting from the first na topics. Okay? Wait lang. Set during the finals week. But then, I think your schedule is June 13 or June 14. So I have to verify. But if you, we can have it. Saan? 153? Be attending the 4th years na defense. Ano na lang, Friday. Yeah, I'll announce Friday night. Para at least hindi siya magsabay sa mga exams nyo. Sa iba. Okay, yeah. So, that's all. I will announce again the dates. And during finals week na yung mga exams na. Okay, so thank you for attending, everyone. Good luck on your exam. Good luck. Ay, may isa pa pala.